Now we're going to look at the inverse of a matrix. We shall start by looking at the inverse of a 2 by 2 matrix. We will proceed after that to looking at how to find the inverse of a 3 by 3 matrix. Inverse of a matrix. 1, 2 by 2 square matrix. The inverse of a square matrix, inverse of a square matrix, A, denoted A, this is power minus 1, which is A inverse, is given as follows. If A is equal to this matrix, then the inverse of A would be equal to 1 over the determinant of A times D A minus C minus D. Observe something that I have done here. We already know that this is determinant. So the inverse of a matrix A is 1 all over the determinant times, you exchange the positions of the elements in the main diagonal. AD, this becomes DA, and sign the two elements in the other diagonal. And that's exactly what I have done in this case. With this, you will find the inverse of a 2 by 2 matrix. Now, this means 1 all over, what is the determinant of A? It means A times D minus B times C. So that is A D minus B C. I take that again. A D minus B C. And this will be multiplied by D minus B minus C and A. This gives you the inverse of a 2 by 2 matrix. As a matter of fact, we will realize later that this element here is the transpose of the matrix A. It is the transpose of the matrix A. So we see that our D minus B minus C A is the transpose. It is the transpose of the matrix A. Now, to find the transpose of the matrix, to find the transpose of the matrix, to find the transpose of the matrix, we first find the matrix of the cofactors. The matrix of the cofactors. First find the matrix of the cofactors. Let's take, for example, We have a matrix A equal to A, B, C, and D. We take the sign of each element, or rather sign each element according to the I and J rule earlier discussed. So that will give us, so we have A equal to A, B, C, D. We sign this, and across, we sign this. After the sounding, we have to generate the cofactors. C. The cofactor C. In generating the cofactors, we are interested in the signs. We are interested in the signs, not the elements. Unlike the determinants, where you pick the sign and the element. But in this case, we are interested in the sign. So the first one has the sign positive. Then you delete every element along the row and along the column. What will be left is D. You take the next one. The sign here is minus. You delete this and you delete this. What is left is C. Then you go to C, this element here, the sign here is minus. You delete this, what is left is B. You take your D and the element there, the sign there is positive. You delete this and this, what you have left is A. This can be written as D minus C minus B, A. So our C is actually equal to this. Remember, we are talking about transpose of a matrix. So C transpose is equal to, is written C T. And the transpose of this matrix is writing the row, the first row, to become the first column. So that is D minus C. The second row to become the second column. Minus D, and that is A. And this is the transpose of the 2 by 2 matrix. And that is why I told us, when we find the inverse of a 2 by 2 matrix, and we have this, I told you that this value is the transpose of the matrix A. And to determine the transpose, we first of all find the matrix of the cofactors. You can see how it was generated. And thereafter, we transpose the matrix of the cofactor to get the transpose of the matrix, as I have written it here. Alright. So this is the transpose of the matrix A.